Okay, now here we are trying to derive some equation in circular motion by using a vector method. Okay, now you know that normally if a particle is moving on a circular path, there is an acceleration toward the center, that v squared over r. Okay, there is an acceleration in tangential direction if the velocity, otherwise if the angular speed is not constant, right? Okay, if anyone is moving on a circular path with constant angular velocity, there is no acceleration in tangential direction, only along the radial direction towards the center. Anyhow, that these results, okay, I am trying to explain you by using a vector method. See, right here Putala, there is a particle P, it is moving on a circle of radius r. This is theta, right? You can think that, okay, now it makes an angle theta with the positive direction of the x-axis. Now this is particle P. I will take at this time the position is Ps comma y. You know that unit vector in this direction I and the unit vector in this direction is j. Standard definitions, right? Okay, now what is OP then? Okay, that OP means the displacement of P relatively O, right? Now you know Putala, OP equal xi plus yj, xi plus yj, xi plus yj. Now that OP you can write again, what is x? If the radius of this locus is r, x is r cos theta, that r cos theta time I plus y r sin theta time j, like this, r sin theta time j. Now here this is the displacement. You know that normally when we differentiate displacement, you will get what's the velocity is. See, d over dt OP. When you differentiate this one with respect to time, here r time, when you differentiate cos theta, you know that minus sin theta time theta dot. That because of cos theta, when you differentiate with respect to t, it is a function of a function. Cos theta, if that become minus sin theta time differentiation of theta d theta over dt. Here my r time minus sin theta into theta dot time I, plus when you differentiate this one, r time cos theta into theta dot time j. We can take like this. Here you know that d over dt OP mean the velocity. Then you have taken v equal, take theta dot out, r theta dot. When you take r theta dot, here you have taken r theta dot time minus sin theta into I plus cos theta time j. Something like this. Now anyway, you have taken the velocity of the object P, otherwise particle P, r theta dot time minus sin theta I plus cos theta j. What is this Putala? Minus sin theta I plus cos theta j. See here. Now that if I am drawing a tangent at this point, okay, and I will extend this line further, I will take the unit vector in this direction, this direction as u hat. The unit vector in PO direction, that means the unit vector, okay, towards the center. And again the unit vector in this direction, right? This direction as L. I will take a different color, then easily you can see. Here Putala, unit vector in this direction as u hat, and the unit vector in this direction as L. I will take like this. L is the unit vector in tangential direction and u is the unit vector in the direction of PO, right? Hurry. Now what is u? What is u? Now you know the unit vector in this direction when r is 1, right? If r is 1, you can take what's the unit vector in this direction. Now that OP was r time cos theta I plus r time sin theta j. Simply when you divide OP by the modulus of OP, you can take modulus of OP is r. Therefore you know that unit vector in this direction, that means minus u hat is equal to what? Minus u hat equal to that when r is 1, that cos theta I plus sin theta j. This is what cos theta I plus sin theta j. Then you had in this direction minus cos theta I minus sin theta j. U hat equal minus cos theta I minus sin theta j, like this. This is the unit vector in this direction. And again, Putala, I need to find what's the unit vector in this direction. That means tangential direction. You know that this angle is theta. When it comes here, more 90. In this direction, that theta plus 90. Okay, then the unit vector in this direction, lamai, okay, minus cos theta I minus sin theta j. Right? No, this is in this way. May patterni. Right now, here unit vector in this direction was that minus u hat. Then when you add 90 here, you will get what's the unit vector to this direction. That means L you can take, okay, vector L Putala, instead of theta, when you put 90 plus theta. What is cos 90 plus theta? Minus sin theta. That minus sin theta I sin 90 plus theta cos theta plus cos theta time j. Now this is L. Now here, anyhow, I have taken the two unit vectors in this direction and this direction. Here you can see, this is what? This is lamai L. Then you can say V equal, now the V equal R theta dot time. Instead of this one, you can put L. Now we know the velocity of a moving object on a circular path is equal to r theta dot, right? And it is in which direction? In tangential direction. May theta dot kyanne kawuda putala? D over dt. Theta equal theta dot. In general, this is omega. Sorry. Angular speed, right? Now the angular speed, otherwise, okay, that velocity V equal, this is linear velocity anyway, that velocity is in the tangential direction, that r theta dot, V equal r omega equation. We have taken by using vectors, right? Okay. You know, normally in a, okay, by using a unit vector, what we do is, right, what we are doing is that normally we are showing the direction. 2, I mean, a vector with magnitude of 2 in this direction. Okay, basics, right? Now the next one, I will try to find what's the acceleration. Now Putala, the acceleration, you need to differentiate this one. Okay, I will try to differentiate this expression. dv over dt. dv over dt. You can see that when you are trying to differentiate this one, Putala, this is a product of two functions, right? See, even this is variable and even this is variable. We can consider like that. Okay. Now, if theta dot t is variable, that means if the angular speed is variable, this, okay, product of two functions, then we have to take that uv dash plus vu dash. Then dv over dt equal r theta dot time differentiation of this. How you can differentiate this one, Laman? When you differentiate this one, Putala, see, minus sin theta time, differentiation of minus sin theta, that goes minus cos theta, right? Okay, see here, minus cos theta time theta dot into I plus differentiation of cos theta. Okay, now here the minus cos theta, differentiation of sin theta was that minus cos theta time theta dot time I, and differentiation of cos theta again minus sin theta time theta dot into j, like this. Okay, uv dash plus vu dash, this one into differentiation of this. Here Putala, okay, we can take minus sin theta time I plus cos theta time j time differentiation of r theta dot, that come r theta double dot, right? Now the d over dt theta dot equal theta double dot, right? Like this thing. Then balana putala mokadda vela tiyenne kiyala. Now here again you can take the theta dot out. Take theta dot out from this one. Now when you take theta dot out, dv over dt, you can say r theta double dot. No, r theta dot t squared, right? When you take theta dot out, that r theta dot t squared time minus cos theta I minus sin theta time j plus r theta double dot time this one minus sin theta I plus cos theta j. පුතාලා මට කියන්න, what was this one? මේ කවුද මේ? See here, this is minus u hat. Okay, instead of this one you can put minus u hat. Now this comes the acceleration a r theta dot square time u hat plus r theta double dot time l hat. This is l. මේ මොකද්ද මේ කියන්නේ පුතාලා? Right? Now here the acceleration r theta dot t squared, that means r omega squared, from the unit vector it shows the direction in the direction of PO, otherwise towards the center, and there is another acceleration in the direction of L hat. ඒක කවුද? r theta double dot. හැබැයි පුතාලා දැන් මෙතනදී බලන්න, the first result was that we found the velocity that was in this direction, r theta dot, because that was r theta dot time L velocity. And again we found that the accelerations, there is a component towards the center, what it was? See, r theta dot t squared, otherwise this is what? R omega squared time u hat. U hat shows the direction, and there is another component in this direction. මේ පැත්තට තියෙන එක්කෙනා කවුද? r theta double dot. මෙතනදී දරුවෝ මේ if theta dot is constant, r theta double dot මොකද වෙන්නේ? 0 වෙනවා. Okay, if anyone is moving on a circular path with constant angular velocity, theta double dot is 0. If theta dot is constant, right, constant, right? එතකොට මේ පැත්තට එන එක්කෙනා කවුද? r theta double dot. Okay, time මෙයා unit vector. Anyway, now here you can see that, okay, in a very nice manner, okay, in a very nice way, that we can prove all the equations related to circular motions by using vectors, right? Okay, anyhow that we derived what's the acceleration towards the center, and what's the acceleration in tangential direction, and what's the velocity in tangential direction, right? Okay, now you can understand how powerful vectors, not only this result, that many results in maths we can prove by using vectors. Okay, if anyone of you want, you can note down this.